This video is all about divisibility rules, or ways of seeing if large numbers are in different times tables. For all of these examples, we're going to use this number here, 27,720. And we're going to go through and see if we can tell quite easily whether this number is in a variety of different times tables without too much effort. Okay, first of all, to find out if the number is divisible by 10, the way that we do that is we look at the last digit and we say, is the last digit a 0? And if it is, then we say, yes, this number is divisible by 10. So 27,720 is divisible by 10. The next divisibility rule is to find out whether a number is divisible by 5. In order to do that, again, you look at the last digit and you ask yourself, is it a 5 or is it a 0? As all numbers that are in the 5 times table end with a 5 or a 0. Well, this one has 0 at the end, so we can say, yes, it's divisible by 5. It's in the 5 times table. Moving on. Is our number divisible by 2? Again, we look at the last digit. To find out if a number is divisible by 2, we're basically asking if it's an even number. So to find out, you look at the last digit and ask yourself, is it a 2, a 4, a 6, an 8, or a 0? In this case, we have a 0. So we can say, yes, this number is divisible by 2. It's in the 2 times table. Now, that's the 3 easy ones over and done with. Let's try the next one. Here we're going to find out if the number is divisible by 9. Now, this is a great trick, and once children know it, they're really happy about it because they can use it and it seems like they're performing magic. So, in order to find out whether it's divisible by 9, all you have to do is add up the digits. So here, 2 and 7 make 9. And these 2 and 7 make 9, so that makes 18 altogether. If you end up with a 2-digit number, then you just have to add the digits on that one, and you get a 9. So the rule is this: if when you add the digits, and you continue to add the digits until you get to a 1-digit number, you get 9. If 9 is the number that you come to at the end, then that means the whole number is in the 9 times table. If it comes to any other answer apart from 9, it's not in the 9 times table. Moving on, a similar rule for this one to find out if a number is divisible by 3. Okay, here we go. Add up the digits. Now we've done this one already and we know that it adds up to 18. Then you add the digits again and that will add up to 9, which helped us to find out that it was in the 9 times table. Now to find out if a number's in the 3 times table, those digits have to add up to 3 or 6 or 9. So in this case, we can say, yes, it's divisible by 3 because the digits add up to 9, which tells us it's in the 9s as well. And naturally, all numbers in the 9 times table will also be in the 3 times table. Moving on, the 6s. Now there's a connection between the 3s and the 6s. To find if a number is in the 6 times table, the first thing you do is you ask yourself, is it even? If it's even, there's a chance that it might be in the 6s, but then what you have to do is check to see if it's in the 3s. So, just like we did just now, add the digits up, we get 18, add them together, we get 9. If the answer is 3, 6 or 9, then we can say yes, it's in the 3s. But because it's even, that means it's also in the 6s, because all numbers in the 3 times table that happen to be even are also in the 6s. To find out if a number is divisible by 4, the only thing you need to do is look at the last 2 digits. They form a 2-digit number, in this case 20. And you need to ask yourself, is 20 in the 4 times table? Now we know, because it's quite a low number and we know our 4s, that is in the 4 times table, and if the 2-digit number at the end is in the 4 times table, then the whole number is in the 4 times table. It might be slightly harder to work out numbers where the last 2 digits are not as low as 20, but here's a little bit of guidance for you. 20 is in the 4 times table, 40 is in the 4 times table, 60 is in the 4 times table, so is 80, and so is any number that ends with 00. So if you get a number like 84 at the end of a longer number, you can say, well, I know 80 is in the 4s, so if I add another 4, that means 84 would be in the 4s. Or you could work it backwards. If you get a number like 56, you could say, well, I know 60 is in the 4s, so going backwards 4, 56 must be. So you can use these little tricks to help you. Another thing to check, of course, is that it's even, because you don't get odd numbers in the 4 times table. The 8s, I would say, is quite a tricky one. There's several different ways to do this, but I quite like this method here. You can look at the number and then you can halve it, so divide it by 2. Here we go, so let's do 27720 divided by 2. 2's into 2 goes 1, 2's into 3 goes 3, remainder 1. 2's into 17 goes 8, remainder 1. 2's into 12 goes 6, and 2's into 0 goes 0. Once you've halved the number, then you've got to look and see if the last 2 digits are in the 4s. So halve it, then see if the last 2 digits are in the 4s. If that applies and you get a number in the 4s, then it means the whole number up here is also in the 8s. Some people prefer just to do a bus stop method, 27,720, and divide by 8. If you get a remainder, it's not in the 8s. If you don't get a remainder, it is in the 8s. You choose your method. Finally, we have 7. Now, unfortunately, there is no easy method to check if a number is in the 7 times table. There are methods around. They're very complicated. So personally, I find it easier just to do a division sum, a bus stop. Let's try it. 7's into 2 doesn't go. So 7's into 27. The closest would be 3, which makes 21. And then you've got 6 left over. 7's into 67, the closest would be 9, which is 63, so we've got 4 left over. 7's into 42 goes 6 with no remainder, and 7's into 0 goes 0. Now, because we've got an answer which does not have a remainder, that means that this number, with all its scribbles, this number maybe, is in the 7 times table. Quite a complicated set of rules. Some of them you already know, but see if you can follow this through and get used to spotting which times tables those numbers are in.